When hello, I went Uncle Cam, so today not for me. But I've got, I think, I've got ICT, Kimberly. I think Kimberly also got something. Where's Kimberly? Kimberly. Hi, Kimberly. Oh, Kimberly outstation. Kimberly outstation. Yeah, it might be start first. Okay, like before we start, dun, 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 how is the current induced out? Right? Xing this one, Sharvini, this one. Sorry, sorry. Sorry. Movement of what? Yeah, very good. Movement of what? You look at the diagram and tell. Sorry, to show you. Then you can see this diagram and tell. First of all, move what? This, this one is move magnet to the wire or the coil. So this one is move wire. This one move wire to, yeah, towards the magnet. Yeah, then. It lines, yes, cut. Yes. Forwards. Mhm. It, the current is produced. Is produced. So what current? If you say current is produced, you must describe what current. Hmm? Ah, where are you read first? Induced current must mention. Okay, so now, so the difference is one move wire, one move magnet. So this one move wire to cut the magnetic field lines. Cut the magnetic field lines. Then induced current is produced in the wire. Okay. So this one, okay, next we are going to learn how electricity is generated at power station. Okay, like we observe first, all of the power plant, power station 其实就是发电厂 ，means it generate electricity 啦。So everything got a generator. See, generator. Not everything, not every. Most got generator, got generator, got generator, got generator. Yeah, like that. So means inside the generator got what? Got two things, two main things. I Ting, please type. Shafini, please tell. Okay, Wen and Kimberly, when you watch here, Kimberly 你来的啊？哦，好啦。when you watch here, you also need to recall inside generator got what Okay, 来 Kimberly, so 怎样？inside generator got what? Got these two things 啦，还有
老师，我现在才刚进来的诶。
好，generator 里面有什么东西？有第一个magnet，第二个 coil of wire，可以吗？So every generator got magnet and wire. Normally we say wire coil because one wire not strong enough. We say the coil. Okay, sometimes we also say the wire coil as solenoid Solenoid. Okay, so now what we do, we actually, sorry last week the charger problem. I just I just send repair or is my what to say the hub of the charger burn. So just pay for that. Then what I want to show you, I want to show you power plant. This is hydro power plant. Sorry, last week show you very small screen.
$170,000 cubic meters of water flow.
This is Niagara waterfall, the largest waterfall in the world. Okay, in the world. So now this is how they built the first dam. Dam 就是水坝 means block.
Electric stations have been designed.
You can see up here
that power is what hydroelectric
Up here actually is the magnet and coil. Up here, inside got coil. They move magnet. The center is magnet. So how they move magnet? They use the water turns this thing we call it as turbine. Okay, turbine normally turns magnet lah. So may I know inside generator need to have two things? What are the two things? Can I share with me? Yes, magnet and wire coil. Okay. Then just last week we also learned number 1 we need magnet. Number 2 we need wire coil. Number 3 we need movement. No movement, also no current. So we need to turn turbine. So turn the magnet lah.
stations have been designed to do for over 100 years in Ontario. In essence, they are factories that convert the energy of falling
So this is the dam lah, block the water.
water into the electron
You can see all of the water block up then flow down. So this is the inside lah.
force.
See, the water is blocked up here. Water is blocked up here, then flows. Here got turbine, then got generator flows down.
Water at the higher level is collected in the forebay. It flows through the plant intake into a pipe called a penstock, which carries it down to a turbine water wheel at the lower water level. The water pressure increases as it flows down the penstock. It is this pressure
Okay, so now this is the turbine just now. Turbine turn what? Turn the neck here lah. Then the side is the coil lah. And jet. So the magnet will have magnetic field line. So while it's moving, it will cut the coil. So then you can see this is current, electric current generated.
flow that drives the turbine that is connected to the generator. Inside the generator is the rotor that is spun by the turbine. Large electromagnet within clear rotor spins the magnet. Electricity that can be stepped.
Okay, then they will send to this one we call it as transformer. We need to step up the transformer first. I will learn what is it later. So then what?
Up in voltage through the station transformers and
Then it will pass through this pylon. This the tower named pylon. Then it got a lot of tower, I believe. You all seen before lah, beside LRT. So one set we call it as National Grid Network. Don't worry, we will relearn this. Okay, you listen to the name first lah. You don't worry what is it. Listen to the name first. Familiar first. Then send to our home lah. Okay. Then the water.
the falling water, having served its purpose, exits the generating station to the tail race, where it rejoins the main.
I will rejoin the mainstream lah. Okay. So now we look at page 4 first. This is the hydroelectric power station. Okay, so this is the water reservoir. The water flows down through the turbine. So inside generator got, right, Xing Xing, inside generator got what? Magnet and, yes, magnet and wire coil. Then we use a turbine, keep turning the magnet so that like Kimberly, so that magnetic field line Kimberly, so that magnetic field lines 这个动作是什么？
cut off.
不是 cut off cuts on the wire coil. Did I tell you cut wire coil is like 割胶 the bubble tea, the bubble? So cuts on wire coil is like we 割胶, we makes the bubble move. You can treat the bubble as current. Okay, so then now we need to learn actually what is the energy change here. Okay, we learned energy last year. I believe you forgot. It's okay. So now when you see this one, got height. Then we say this energy is gravitational potential energy. Okay, so gravitational potential energy, when they start to flow, starts to move, they will change to kinetic energy. So the mechanism is high gravitational potential energy. Water flows from high level to low level. Flows of water rotates turbine, all are movement. So movement means got kinetic. The energy for movement called kinetic energy lah. Okay, then the generator will produce electricity. Yeah, then it will turn to electrical energy. Okay, then we go to page 3 first. Same thing, sure, got generator. Then here got the turbine. Turbine got many shape. The shape like this means we are using steam. Steam is gas. The hot steam turns the turbine. Okay, since it got hot steam, means we need a fuel to boil water. So you can see water comes from here in the pipe. They become gas, then they become steam, turns the turbine, cool down. So when it cool down, we got a condenser cooling system, and both are water, but they are in different system lah. Then they will be pumped back. So now this is the thermal power plant.
Thermal power plants help meet almost half of the world's power demand.
Yeah, so you can see all over the world. Actually, we in Malaysia also 70% is thermal power plant. Why? Because we got coal, we got petroleum, oil, we got natural gas, and many lah. So 70% we are still using this. Okay, so you can see the rest is like thermal power plant, nuclear power plant also is a thermal power plant, but later we'll study this. Hydroelectric, just now we know already lah, using the river water to rotate the turbine.
They use water as the working fluid. Today's thermal power plants are capable to run under great efficiency by conforming to stringent environmental standards.
The turbine looks like this, different from water. It's very thin and very easy to turn by gas.
In this video, we will see how a coal-based thermal power plant achieves this in a detailed step-by-step manner. By turning the shaft of this generator, we will be able to generate electricity. The generator derives motion from a steam turbine, the heart of the power plant. As the turbine absorbs energy from the high-energy fluid, its pressure and temperature drop.
So the steam turbine in this way, then it's actually started from this one too detailed. I do not need to learn so detailed. I just need
The
to
easy
learn.
way is to convert
You just need to learn the steam flows through, then they start turning turbine. They start to turn magnet inside.
the steam into liquid and boost the pressure. A stream of cold water flows through the tube.
So this one is the cooling system. When the steam turns the turbine, it flows down. And
In the condenser, a stream of cold water flows through the
here is a condenser, means it's a cooling down system.
tubes.
Yeah, so see the steam will be cooled down by the flowing water.
The steam rejects heat to this liquid stream and becomes condensed. Now we can use a pump to increase the pressure of this feed water. The next task is to bring the temperature back to its original value. We generally use a type of boiler called a water tube boiler. Pulverized coal is then burned inside the boiler.
So we say this is thermal power station. Thermal means heat. We use heat up the water becomes steam. So that's why here got fire. Then how to make this fire? We can use our country. We use petroleum. We use coal and we use natural gas because our country have. Okay, then some extra information exam 1 Tesla. Our Malaysia's petroleum is very good petroleum. So we actually export out this good petroleum export. Then the price is good, so we import in the less quality petroleum. Okay, then supply to Malaysians. Do you know how much for RON 95? How much per liter? Never observed. Okay, now it's fixed. It's okay because you all don't have car. 2 ringgit and 5 cents. It's really, really cheap. Because because the government got the supply for this, so it's cheap. If we go like other country like China, their RON 95, 1 liter needs around 6 ringgit. So most of them just use RON 92. Then if RON 97 in our country, I think 3 ringgit something. I don't know. I don't use. I feel but actually very good. Okay, the engine exhaust everything cleaner. But pricey. Okay, then do you know that? I think you don't know. Do you know that the government said since not sure when soon, when you want to pump petrol, you need to use IC, insert IC first. Yes, because they don't want to give this our cheap petrol to the foreigner. Now the foreigner also use this price. Okay, by the way, thermal power plant means we burn something, heat up the water. Thermal. That's why burn something means will produce smoke, will produce carbon dioxide. called a pollution.
The incoming water initially passes through an economizer session. Here, the water will capture energy from the flue gas.
Yeah, so this one water, they burn water inside here, then water turns into gas.
The water flows through a downcomer and then through water walls, where it transforms into steam.
And now
The
becomes
pure steam is separated at a steam drum. Now, the working fluid is back to its original state, high pressure and high temperature. And the cycle can be repeated over and over again.
so now the steam will turn into turbine, then cool down and pump back to reheat. So the cycle repeat and repeat lah. Okay, here is turbine. Here is generator. Inside generator got what, Kimberly?
Got magnet wire coil,
Yes,
which is solenoid.
yeah. The rest too detailed lah, no need lah. Okay,
At the condenser
last
with the help of a
is
cooling tower. The heated up water from the condenser outlet is sprayed in the cooling tower, which induces a natural air draft, and the sprayed water loses.
okay, so then we got this tower as cooling tower. So yeah lah, while it's cooling, it need to release heat energy. So we blow air out so that makes the cooling faster. More fan means more cooling faster lah. That's why most of the
Coal produces many pollutants. To absorb the pollutant part, they use water.
most of the time you will see thermal power plant sure got smoke. This smoke actually for burning of coal. Burning. This smoke here is the water vapor that cooling by the wind lah. Okay, now ta-da. Okay, fuel, boil water, use steam, turns turbine, cooling, and come back. Now, next, burning of fuel. The fuel will have chemical energy. Okay. The food also got chemical energy. Our food also got chemical energy. Then boiling water produce steam. Boiling water means it got heat energy lah. And steam rotates the turbine. Means rotates is a movement. What is the name of movement energy? 来，心情。忘记了。好了，key 什么？key 好了，kinetic energy 啦。哎呀，心情啊。Let's memorize. Okay, then kinetic energy will turn the magnetic flux cut on the wire coil, so will produce produce electricity. Maybe you all like cancel electricity, you all write here. Produce induce current. My housemate, my cousin. All right, so now we are for our Malaysia. Oh, sorry. I should not say petroleum. Actually, we are using diesel inside the petroleum, natural gas, and coal. By the way, do you all see diesel in petrol station? The word's diesel. I ELA. Yeah, so be careful, normally we don't pump to the wrong one. So diesel, they will write diesel, really black. Normally around 95 yellow, 97 green. If you pump 95, 97s, it's okay because they are petrol. So doesn't matter. Just if you pump diesel into the petrol car, it will cause damage. So let's say you find out, oh yeah, I pump diesel into petrol car. You must not start the engine, directly call mechanic. They would tow your car to the mechanical shop. They will absorb, what to say? They will, they will pump the diesel out and clean everything. If not, your engine will burn. Okay, so so very rare but in case this happen, maybe not you, your friend, stop them to start engine. Okay, directly call parents. If no parents, also can ask the help from the workers lah from petrol station. Okay, so now next is we look at wind first lah. Page 4, wind. Okay, power station using wind energy. This generator is very tiny. Okay, so same thing lah. By the way, for wind turbine, we use the blade lah. Okay, so we use moving air or wind by using kinetic energy. Wind moves blade rotates. See, moves. So finally, it will generate induced current. Okay, so finally, it will have electrical energy. Okay, so this one we can see it. Normally we say it's wind turbine. Wind turbine in Pulau, I think Pulau Kecil in Terengganu. Very nice. Actually, they got solar energy together. I was there before lah. I was there traveling, school trips traveling. So I feel proud lah. The small island, they use wind turbine and solar together. Okay, yeah, then solar energy lagi easy lah. Nowadays, now TMB changed their circular already. Last time TMB said you use, let's say your solar panel can create 500 ringgit electricity. Let's say you just use 250. Then the 250 you can sell back to TNB. As last time, not much people will install this. Install this, the cost is around, I heard lah, the cheapest is from 30,000 to 50,000, depends. Depends on your house roof, because maybe not facing to the sun side. You need to adjust. And depends on how long is the sun shines on your house roof. Okay. But so last time can sell back. Now is TNB won't buy lah, but they would use this as like a touch and go credit lah. They save there, they save. So let's say next month you use a lot of electricity, you can deduct that lah. But I am not too sure why still need to pay for some money lah. My relative, they install this. They say sometimes need to pay like 10 or 20 ringgit. Yeah. So let's say if you have landed house and your house bill is more than 600 ringgit per month, actually can think of installing solar panel cell. My condo cannot. And my electricity, I think less than 160. Okay, so this mechanism very easy. Use solar sun rays, then directly convert light to electricity. This one no need magnet, no need. Directly it turns. So we say solar energy change to electrical energy lah. This one is the easiest. Okay. I think got pros and cons. I didn't study much lah, but so far solar energy is the way more environmental friendly lah. The things that not good is the material inside is like hard to recycle. So let's say we use for 30 years and the lifespan 30 years, and seems like I cannot recycle the material. Okay. Okay, then next we look at nuclear, which is page 5. Okay, so same thing. Let's look at generator first. Shabini, what's in the generator? Magnet. Yeah, and wire oil. Okay. So now we can see what turbine looks like. This means yes, we are using steam to turn the turbine. And we got condenser. Normally we use seawater to cool it down. Then the water pump back and into the nuclear reactor surrounded here. So actually the water is not directly contact with the nuclear. Then we just use the heat energy inside the nuclear reaction, absorb them and mix water as steam to turn the turbine. Okay, then right now, next we are using nuclear reaction, nuclear energy to boil water. Boil water means what kind of energy here? Yes, boil water means got heat energy. And the heat energy will It makes the steam rotates the turbine. Rotate means, yes, means movement, means kinetic energy. And the generator produces induced current. All right. So you produce electrical energy lah. Okay, let's see where is my nuclear power? Where is my nuclear power plant? We will relearn this in Form 4, Form 5 Science and Physics lah. I think Form 5 Science and Form 5 Physics. And now we just know the general first. Nuclear power got the pros and cons. So this is, I don't know who say, Einstein. First man split the atom. Yeah, nuclear actually is we split the atom. Now the atom splits the man. So I believe you all now learn sejarah, Hiroshima and Nagasaki. Right? No. Do you know the World War II ends by the two nuclear bombs? So because at that time the Japan don't want to stop the war, so no choice US. I don't know how is it but US say no choice, they need to release the bomb to stop them. Yeah, so they bombed the two places in Japan. Number one is Hiroshima, number two is Nagasaki. Then finally Japan say, okay, we surrender, we stop. Because actually the Japan starts the World War II first. And including Malaysia was dijajah sepanjang 3 tahun 8 bulan. I think your parents may go through it. Sorry, your parents may not go through it. My parents go through the time. I think I'm elder than you all, around 20 more years. I think your parents is almost my age. So I didn't went through. My parents went through. Okay.
Nuclear power plants are thermal power stations which
So they say nuclear power plant is a thermal power plant too, because we heat up the water becomes steam.
important of which houses nuclear reactors, heating tower, principles, heating tower,
Same thing, we also got cooling tower lah.
which can be as tall as 200
200 something, quite tall.
meters, is where hot water is cooled. In order to easily
And by the way, the nuclear power plant was built near to the riverside or seaside because they want to use the seawater to cool it down. And later we discuss about the Fukuoka. There is a nuclear power plant cracked before.
understand that used a pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressure 12 meters tall, assemblies are in what is about the nuclear in the order to absorb the thermal energy and
Okay, can you see actually the nuclear is inside the rock. Then the water goes through it, absorb the heat and heat up becomes steam. So now this water will heat up become steam. Steam. Here water, here steam. And then we are going to learn sorry, nuclear. in chapter 8. So like before that, let's show you, this is the nuclear field. And uranium. So we say that we actually can say the nuclear power plant is a good energy because it's not burning, so it won't produce carbon dioxide and not produce smoke. Then it can have heat. But the problem is it will makes people have cancer. Okay, so actually 10 grams of uranium is equivalent to 1 ton of coal. 1 ton means 1,000 kg of coal. You burn 1,000 kg of coal, the heat energy you burn, same as 10 grams of uranium release the heat energy. So compare, the cost is very low cost. I imagine buy this also costs a lot. Or 454 liters of oil. Do you know pump one car only needs around 27 liters oil? So this one can pump around 20 cars. But 10 gram is, what's the idea? Okay, your stapler bullet. And one stapler bullet the size can equivalent to the heat energy produced by all of this. So consider safe cost. Right, so now uranium will have nuclear energy, generate heat energy, heat up water into steam. Steam turns turbine. Turbine turns magnet into the wire coil and produce induced current or electrical energy. Okay, so last. By the way, at the end of this, I want to ask you, what is the power change? Yeah, from here to here. Not hard, right? Not hard. Like repeating only. Last is power station using biomass. So we say biomass power station. Actually, this is also a thermal power plant, just that this gas is more clean. More clean. So biomass produce methane. Do you know? Okay, methane is what is it called? Flammable gas. Okay, so by the way, the biomass is chemical energy. This chemical energy will boil the water, so it will produce heat energy. Okay, then the steam will rotate the turbine. Rotate means move the turbine. So it's kinetic energy. Then this generator will produce electrical energy. Okay, so same thing, heat up the water, becomes steam, turns the turbine and come back. Now what's the problem is, what is biomass? Now anyone can give example of biomass? Really no idea at all. OK， 来，心情 Kimberly 知道什么是 biomass 吗？
里面都是有很多那种粪便的。
对呀，feces，animal feces。
老师，我其实有点不敢讲，因为我觉得很恶心。
It's okay, especially cow dung. Uh, cow dung. Cow dung means cow feces. Because cow feces really can have a lot of methane gas. I'm not too sure how. I think it's because the digestive system of the cow will produce the methane. Means very pungent smell. For example, our Malaysia got a lot of paddy field. So paddy husks, paddy leaves. We just want the paddy rice. We don't want the husk and leaf. For example, we Malaysia got a lot of sugar cane. That's why our sugar is can say the cheapest lah among the world. I can say we export out sugar from the sugar cane. We just want the juice inside. We don't want the leftover things, residue. So we put it in, and what else? Leftovers from kitchen. Leftover from kitchen. What else? I believe we all always see the green plastic bag stacked around beside the roadside. Do you see before? Not so sure. Okay, I dropped. Do you see people? Sometimes they like blow the drop leaf around. And do you know why they blow the drop leaf? Don't know. They want to collect the drop leaf. APJ. Why they collect it? Yes. The drop leaf also can use it as biomass. Drop leaf and oh wow. Okay. Drop leaf is Botanic Jaya is color. And this one, the coconut. Our nasi lemak very good. So also got a lot of coconut is used. So the coconut husk also is used as biogas. By the way, banana leaf also tastes nice. Leaves. It's okay. As long as you see the people blow the drop leaf before. So how is biomass work? How is biomass? How is we also call biomass is is less pollution. Okay. It's less pollution, has less pollution. Text version done.
How biomass works. Biomass is the name for a range of organic materials that can be used to produce energy. Examples include forestry products, energy crops like miscanthus, also known as elephant grass, and agricultural byproducts like straw. We can generate heat or electricity from biomass in a way that is close to carbon neutral over the material's life cycle. To understand the environmental benefit of using biomass, let's look at how fossil fuels like coal, oil and natural gas.
Okay, so normally oil is our petroleum. Coal will be on surface. Gas and oil very deep in the
Are
ground.
created. Plants absorb carbon dioxide or CO2 from the air as they grow. When they die, some of the carbon from the CO2 remains trapped in the decaying vegetation. Over millions of years, these buried layers of vegetation are compressed and transform into either coal, oil, or natural gas.
Okay, so we want something to be burned because inside of carbon. So we breathe in, not we breathe in carbon dioxide. How we absorb carbon dioxide? No, sorry. We absorb in carbon because we eat the plants. The plants want carbon.
The carbon that was removed from the atmosphere is effectively locked underground. Now let's look at two ways you could heat a house. The first example uses a fossil fuel, coal. Coal is extracted from the ground and transported to the house. This process produces CO2 emissions. The fuel is then burnt, providing heat. CO2 from the fossil fuel is released into the atmosphere, increasing CO2 levels. Coal reserves are being depleted and atmospheric CO2 levels are rising.
So this will cause the greenhouse effect. So when we burn carbon dioxide, release more carbon dioxide.
This life cycle is unsustainable. Let's look at a biomass alternative, in this case, wood. A tree grows absorbing several years' worth of CO2 from the atmosphere. The carbon from that CO2 is trapped within the tree. Firewood is harvested and transported to the house. This process produces CO2 emissions, and we will come back to these later. The wood is burnt, providing heat. The CO2 absorbed by the tree is released back into the atmosphere.
Okay, so if you use biomass, so it's like it absorbs and return. But that one is we release the carbon from million years ago.
New trees are grown and the cycle continues. The fuel is being replaced and CO2 emissions are minimal. This life cycle is sustainable. CO2 emissions from processing and transportation can be offset by growing more biomass than is required for fuel. We have shown how biomass can heat a house, but the idea can be scaled up. Instead of using the wood for heat, it could be used in a power station.
Okay, this is just the recycled carbon. What I want to show you is
Renewable Energy 101. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas.
Okay, methane gas is very good burning gas, which we use in, what is it called? Camping fire methane gas. Okay, if you have camping before, okay, oh, butane, that is called butane gas. I believe you all see this before, right? Butane gas. So almost the same thing, just the way they process different. Butane gas is easily to burn. So you can imagine is this process produce a lot of easy burning gas.
The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop.
Yeah, correct. Power to the poop. Correct. Oh, of course, we can
A
use.
renewable called biomass generates less than 2%. Harvesting to change that.
Power your home and live completely off the grid by just using your own trash.
Yeah, one trash.
The 8.3 billion metric tons of plastic produced worldwide, only 9 mass pellets are what Entrade's power units run on. The company has also developed the technology to use
Bring to the middle of nowhere.
these pellets at home.
Can offer this for the price of a small car.
Entrade hopes
This, not this. Biomass. Try this.
The plant supplies the distilled wood chips from the municipality's management of its trees and shrubs. They are delivered in lorries and tipped into a feed system, which in turn feeds the plant. As wood chips are a CO2 neutral, renewable fuel, the plant produces 180 degrees C. After through the bag condenser and cool flue gas, the temperature of the line can continue to operate.
Yeah, it is a complicated process. That's why I think hard to tell at once. You just remember biomass is using all of the waste product. By organic waste product means that can be decomposed and it will produce methane gas. Methane gas burn the water, becomes steam. Steam turns the turbine. Turbines turns the magnet. Let the magnetic field lines cut the coil into the generator, generate electricity, and it will be cooled down and steamed again. That's it. Okay, so that's all for power plant. Now what I want to ask is, what is their energy? So I'll show you the diagram. You tell me one by one. From what energy to what energy, lah. Okay? Okay, I give you 1 minute. I go fill up my water. Fill up my water. Okay, right. First of all, hydroelectric, right? Kimberly, what energy is changed during the process?
So first is chemical energy.
Hydroelectric. What height? 有高度的胶，有高度的胶。
It's gravitational potential energy.
换成
Kinetic energy. 最后 electric energy.
electrical energy. Okay.
Electrical energy.
来，心情 ，Bill 有什么 energy？係咪啦？係啊。Oh, okay. Okay, good. Right, this one short. So you need to tell two. Right, solar energy. Then electrical kinetic energy to electrical energy. Good. Right, nuclear power plant, Kimberly.
The first one is nuclear energy, and second one is heat energy. Is kinetic energy, and last one, right? Of electrical energy.
Good. Right, biomass, Jarvini. Good, okay, that's it. Now look at DC and AC. Okay. DC is an electrical current that flows in one direction. Okay. Example of devices. Is DC, for example, as long as you use battery, then it will be DC. For example, torchlight, calculator, and toy car. So, by the way, battery. Last time we said battery, but starts now we are going to learn battery. Maybe sometimes we say dry cell. Because car battery is wet cell, but we don't say wet cell, we say accumulators. Sorry. Okay, accumulators, or we use solar energy. Okay, then AC, not aircon. It's alternating current. AC. Okay, alternating current is an electrical current that flows in constantly reversing direction. So look at photograph, this one. So AC means the current flows up and down, up and down, up and down. So this is the brake toaster, hair dryer, aircon. Do you notice all of these are electrical appliances in home? That's it. So AC flows like this. Okay, DC is, we can say DC. AC actually doesn't mean the wave. It means that the current flows up positive, then flows down negative. DC could be flow up, so either a straight line or a curved line, doesn't matter, as long as it's above positive. I show you some example. Then how can we observe the AC or DC? We can use a cathode ray oscilloscope, CRO. And normally in PT3 in UASA, I never see this but now UASA is your school internal exam. So if your teacher find out CRO is good to have a question, then okay, then they will come out the question. So we just practice that. Okay, CRO is an electronic device that I use to show the difference in the shape of graph, direction of current, and voltage change. So far they won't test you about this. It's like this. You just look at the screen. The screen is here got the x-axis and here got the y-axis. Then you will see if the current direct like this. If the current is AC, it will have wave like this. And I believe all of you seen the drama before. No CRO. Drama, normally a patient going to die, it will have ding, 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 ding. This one actually is a type of CRO. That's the heartbeat. Actually, heartbeat is an electric signal. We learned this. Nerve impulses is an electric signal. Okay, so now CRO, how it works.
We are recording. Okay, welcome back. I'm here again with Miss Lumsden.
Hi there.
And Mr. Perry.
Yep.
Where it lights up. Now we're going to leave the voltage scale on 0, but we're going to change the time base. So we're going to basically alter the x-axis, which is by putting a
X-axis is time base, means timer. Okay. Then let's see.
Now, what we might do after that, plot, say 3 squares up for a 3-volt battery.
Y gain means voltage. By the way, this one, we can say the x-axis is time base. Then the y-axis is voltage. Okay, voltage. Okay, so when nothing improved, then the times like that stop. Time start means it will sweep a line like just now. Sweep a line.
Negative, positive, the negative, the electron beam is deflected one way and then the other one way. And
so Y start means behind there the beam is sweeping. Okay, sweeping inside.
Then the other, which makes it look like a solid horizontal line.
So I see it goes one way quite
When it starts X, so you will see a horizontal line.
slowly, but then it quickly flicks back the other way?
That's correct.
Okay.
The next thing we're going to look at after that is when we change the time base back to 0 and we put a battery, a simple DC voltage, across the y-axis. So now, instead of the electrons being deflected left
Now see, if we put one battery here, our voltage will rise up.
and right horizontally, they're going to be deflected vertically by the Y plates. And in this case, with a simple DC voltage, they're just bent up towards the top of the screen. And you'll get a dot, say 3 squares up. For a 3-volt battery, it'll be 3 squares up.
So let's say 3 volts, it will jump 1, 2, 3. So now see, if we put one battery with time base off, means no x-axis. So it will, see from center, it will jump up 1.5. Then when time base on, then it will go through the straight line. So it will become 1.5 volts. Okay. Then if we double it, then it will drop down negative 1.5. But anyway, it's also drop down negative 1.5. But anyway, it's still DC because up positive, down negative, no matter totally positive, totally negative, still DC, direct current. Then comes to this AC. So if we don't let the X off, means it only up, down, up, down, up, down. Okay.
Oh, okay, so it's like 1 volt per square.
Exactly.
So your negative electron
Being attracted towards the
Oh. In the video. Maybe next time.
next time we'll have a look at that.
Yeah.
Oh, the video's still going. Oh no, it's not.
Oh no. Okay.
That yeah, that wasn't all the video. Was
And just now, down is we flip the direction of the tree.
What the hell?
Okay.
All right, we'll do that.
That taken. So we've got that combination and wrap up what you can do with a cathode ray oscilloscope. So there you can see the 5 volts is shown controlled. Here we go. Yeah, so now it's moving up and down and it's moving left to right. And so overall we're going to get that kind of sine wave shaped graph being displayed on our oscilloscope. So that's the combination of an alternating current on the Y plates and that sort of alternating current on the X plates, but the alternating current on the X plates is carefully controlled to move the electrons across the screen.
Okay. So if AC, you will see up, down, up. Okay, this is the ballet. So first is from positive to negative, the ballet from negative to positive. So what is the inference? Inference here we say time base, no, we say inference. The line is on x-axis, means no input voltage. No input voltage. Time base on, off means you cannot see it move left, right. Time base on means you can see the line move left, right now. Okay, so this one no input voltage, and then this one will have direct current. Direct current positive 1.5 volts. Because we connect on the proper place. Okay, then this one is direct current negative 1.5 volts. Then this one is, what do you think? What current? Oh, yeah, alternating current. Alternating. Okay, so this is alternating current. This is, you can see two boxes, one box, two box means 2 volts. Alternating current, 2 volts. Just that it started positive. 2 volts, we don't say positive, negative, because always change positive, negative. And this one is also alternating current, 2 volts. Okay, let's say if our house got the disruption of electricity supply, then our government will give a giant generator known as genset from TNB during the disruption. I'm not too sure, 2 or 3 years before in Taman C, we got a really bad electrical disruption. So I can see this truck come to our school. Okay, so now example of innovation to generate electricity. We use roof with solar cell. And we use wireless electrical transmission and distribution without wire. So now, right? Your homework today is page 9 and 10. Okay, page 9 and page 10. This is one. Okay, where is 1 3? 3 is science. Homework page 9 and 10. Okay, so 1 more minute, right? This is a transformer. Okay, near to LRT center. Alright, then this is the theoretically transformer with the input on left and output on right. Okay, then we see here got primary coil and here got secondary coil. This is the AC supply and this is the load. So the input always AC, output also always AC. We remember the name first. This coil, we call it as primary coil. Then this soft iron core, we call it as laminated soft iron core. You know what is laminating paper? Laminating paper. We put a plastic on paper. Laminating paper. So this laminated soft iron core, the same thing. We laminate the soft iron core piece by piece, then we glue it. Okay, then so this is output. So output we say here is secondary. So The numbers of coil recorded as NP. Voltage for input we say BP. So numbers of secondary coil we say NS. Voltage of secondary coil we say ES. Okay, then next week we are going to calculate a lot. Please bring calculator. Okay, so that's it for today. Thank you everyone. Bye bye.
Thank you, teacher. Bye bye.